High-performance chips are needed to build our future, whether it's for artificial intelligence or driverless cars.
The key to producing advanced chips is by generating extreme ultraviolet light.
EUV light is revolutionary because it has a much shorter wavelength compared to visible light. This allows EUV light to create extremely small structures on chips, circuitry that's 10,000 times thinner than a strand of human hair. The more structures that are packed onto a chip, the more powerful the chip becomes.
But the thing is, EUV light doesn't occur naturally here on Earth. It's only found in outer space.
So how do you generate EUV light on Earth? That's where a powerful laser comes into play. A Trumpf laser from Germany. No, it has nothing to do with the former US president. This high-powered laser strikes tiny droplets of the metal tin in a vacuum chamber as they shoot past. We're talking about striking 50,000 droplets of tin in just 1 second. The giant laser takes 2 shots at each droplet. The first flattens the tin. The second, bigger pulse, vaporizes the tin, creating a plasma that generates the prized EUV light upon impact at the desired wavelength of 13.5 nanometers. Light is projected through a blueprint of the pattern that will be printed. In a previous video, I explained how mirrors made by the German company Zeiss focus the pattern onto the silicon wafer, which has already been coated with a light-sensitive chemical. The wafer is eventually split into little pieces of microchips. No other laser on the market can hit 50,000 droplets per second at precisely the right moment, not a moment too soon or too late. Otherwise, the impact will not flatten the tin droplet. So Trumpf's light beam must be shaped in a very specific way. Each laser pulse consists of a small, compact group of light particles hurled at the tin droplets in a tight bunch. The plasma that is generated is extremely hot, with a temperature of 220,000 degrees Celsius, or 396,000 degrees Fahrenheit, which is 30 to 40 times hotter than the surface of the sun. The Trumpf laser is used in the Dutch firm ASML's huge machines that perform the crucial step in the chip-making process of printing tiny patterns, circuitry, on silicon wafers. ASML is the only company that is currently capable of building the world's most advanced system needed to print chips, its EUV lithography system. Less advanced machines, its deep UV lithography systems, can still print quality chips, just not the most sophisticated kind.
Think of it this way. If you were to write your name with a highlighter in smaller and smaller font, in order to write an even smaller font, you would eventually need to switch to a pen. So an EUV lithography machine is like that finer pen.
If you own a relatively new smartphone or smartwatch, you've likely benefited from EUV lithography technology. So far, China has not been able to get its hands on these sophisticated machines. When President Trump was in office, he pressed the Dutch government not to sell the most advanced machines to China. The Biden administration has continued putting pressure on ASML amid the ongoing chip war with China. Washington's sanctions in October banned U.S. citizens, permanent residents, and green card holders from supporting the development or production of advanced chips at certain factories in China, which could affect hundreds of people working for Chinese semiconductor companies. And perhaps it could force them to choose between their citizenship or their job. As a result, ASML sent a memo in October instructing its U.S. employees to stop servicing Chinese customers. The memo says they are prohibited from providing certain services to advanced fabs in China until further notice. A fab refers to a chip manufacturing plant. ASML has several locations in China for research and development, manufacturing, and training. However, at present, it does not sell its most advanced EUV systems that use the Trumpf lasers to China. So a tightly connected group of European companies rule the technological world in many ways. The Dutch company ASML is the only firm that manufactures advanced machines to build the circuitry for high-end chips. It relies on Trumpf lasers to generate EUV light to pattern the finest lines on microchips. And mirrors from the German company Zeiss collect and focus the EUV light. I've done videos on all 3 companies, which I'll link to in my description. Other chip makers then use their EUV systems to manufacture their own microchips. Intel, Samsung, and TSMC. Taiwan Semiconductor Manufacturing Company makes nearly all of the world's most advanced chips. TSMC currently produces 5nm chips and is striving for next-generation 3nm ones. So when we talk about the future of tech, TRUMPF, Zeiss, and ASML are critical pieces of a puzzle that together are shaping the world of tomorrow. It would be impossible to build sophisticated chips without brilliant engineers. If you'd like to improve your science, math, and engineering skills, Brilliant is a website and app filled with interactive puzzles like these. In this scientific thinking course, you have to figure out what the light intensity will be after light passes through all 5 filters. I know my viewers also really love Brilliant's Computer Science Fundamentals course, such as this course on neural networks. I use Brilliant myself and especially enjoy their logic puzzles. It's made me a much better thinker and problem solver. There's something for everyone on Brilliant, whether you're a student or you're already working and wish to brush up on what you already know. They've got a whole host of interactive math courses which will help you see numbers in a new light. Brilliant is free for you to try out if you head to the custom link in my description, brilliant.org/newsthink. And the first 200 people who use my link to sign up will get 20% off Brilliant's annual premium subscription, which gives you unlimited access to all of their course offerings. Thanks for watching. For Newsthink, I'm Cindy Palm.